Here are a couple of strategies for multiplication. The first one we're going to call double and halve. The idea here is that we're going to cut one of the factors in half while we double the other one. We're going to do it strategically so as to make our lives easier, less complicated and not more complicated. For example, if I'm going to multiply 64 times 5, multiplying by 10 is usually pretty quick to do. Just tack a 0 onto the end. So if I divide 64 by 2, so this is the half part, cut 64 in half and I get 32. And to compensate for that, I'm going to double the 5. So I've divided by 2 and multiplied by 2, and the net change is 0. It's a wash. Now I have 5 times 2 is 10, and I've just changed this into something that's really pretty fast. That's 320. Here's another example of that. What if I want to multiply 25 times 32? Well, 25 is odd. I certainly don't want to cut that in half. It would be a fraction. But what if I divide 32 in half? Then I'll have 16. And if I double 25, now I have 50. 50 times 16. Well, 5 times 16 is 80 with an extra 10. Total is 800. And that's probably faster than if I had tried to formally multiply 25 times 32. Another strategy that we can use is the distributive property. And that is to realize that these two-digit numbers are tens place and ones place. So if I want to do, let's say, 54 times 23, well, I can multiply the tens place. That's 50 times 20 without 2, but essentially that's one-digit multiplication. And then 50 times 3, make sure to carefully stack up my place values over here. And then this is 4 times 20, which is 80, and 4 times 3, which is 12. And now I've changed this into an addition problem. So I have 14, 1,242. We can make a visual model of the distributive property using a rectangle. So I'm going to call this the rectangle model. And we'll do the same problem again. Here's what it looks like. I'm going to draw a rectangle. Probably guessed that part. And we're looking at 54 times 23. So 54 is 50, which I'll put across the top, which is most of this space here, and then 4 is just a little bit at the end. 23 is most of this space. Sorry, it was right the first time. I should have stuck to it. Is 20 is most of that space, and then 3 is just a little bit there at the end. Now I'm going to multiply. 50 times 20, that's 1,000. That's the same total that we got before when we multiplied 50 by 20. The rectangle just helps us to make sure that we get all 4 of our partial products instead of doing 2 and calling it a day. 50 times 3 is 150. 20 times 4 is 80. And 4 times 3 is 12. And just like we did above, we'll take those 4 partial products and add them. And we better get the same total that we got before. So distributive property and then the rectangle model is a visual representation of the distributive property.